In this video, we briefly talk about ACES before discussing it at length later on in the rendering section of the course. Obviously, it's quite soon to talk about ACES as we are just starting the course, but as I'll be using ACES workflow in most of the lessons ahead, I just wanted to give you a quick introduction about what ACES is and how to set it up in Octane for Cinema 4D. Just a heads up, this lesson will contain a lot of push this button, push that button without explaining why in a lot of details, as it is a very complex topic with lots of technical jargon. We'll learn more about why we do what we do in the rendering section when learning about ACES itself. So ACES is a system of color spaces and color management solutions that, through a set of mathematical specifications and guidelines, allows for a fully encompassing color accurate workflow with seamless interchange of high quality images and textures regardless of source. That is a very loose definition of what ACES is, and it has certain advantages when you implement it in your CGI rendering workflow, like being able to use a much wider and brighter and saturated ranges of colors and lights without having to deal with burnout highlights and inaccurate colors, or simply put, it's very good at preserving highlights, shadows, and colors. It has a filmic response curve, a much wider color gamut, which makes it perfect for archiving and much more. Let's just leave it at this for now. I know you are probably more confused than when we started this video, but more detailed explanation will be given in the ACES lesson in the rendering section. Now, how to get this working in Octane for Cinema 4D? There are two ways to work with ACES in Octane for Cinema 4D. The first one is a one-click solution that would get you started with ACES, but it would have some limitations when exporting your render and specifically in comp. And the second solution has a few more steps to set it up, but gives you the full treatment, and we will use that more often. Let's take a look at the first solution. First, let me open up the live viewer and lock the resolution in the live viewer. So when we start the render here, the resolution would be exactly the one we specified in the render settings, which in this case is 1280 by 720. You notice at the bottom of the live viewer, we receive a lot of information regarding the scene. If you click a few times in the live viewer, you would see less or more information. I'm going to click a few times just to see the least amount of information to get a cleaner live viewer. Right now, we are in the default linear sRGB color space, and we are rendering using this Octane camera over here. If I select the Octane camera tag and select the camera imager tab, all we need to do to start using ACES as the color management solution is to enable camera imager and then enable ACES tone mapping. And as I turn this ACES tone mapping option on and off, you can see how we get ACES and a much more attractive look and feel. Effectively, right now we are in ACES when this ACES tone mapping option is turned on. The problem with this option is that it won't give you the full ACES pipeline in post and in the compositing stage. So if you are planning on exporting out a JPEG or a PNG image straight out of Octane and you don't need to think about compositing and linear EXR outputs, it will suffice you. But this option cannot export linear outputs. So if you are planning on exporting OpenEXR linear outputs and have a compositing stage in your workflow, you need to learn the second way. For that, let's disable ACES tone mapping and close the live viewer. For some of the lessons ahead, we will just enable this option without committing to the full ACES workflow, as it will be enough and faster to set up. First, we need to make sure Cinema 4D itself uses OpenColor.io internally as the color management. And to do that, you simply press Ctrl D to open up the project settings, then come down to the color management section and change the color management from basic to OpenColor.io. Set the preset to ACES, set the render space to ACES CG or ACES 2065-1. ACES CG is a subset of ACES 2065-1. Sometimes I just use ACES CG, but to get the full range, you can use ACES 2065-1. And now set the display space to sRGB, and finally set the view transform and thumbnails to RAW. So basically, Cinema 4D internally renders in ACES, and then the result will be shown on our displays in sRGB because that is the color space that most monitors support. Next, you need to download OpenColor.io or OCIO configuration from GitHub. Just Google color science, open color IO configs, and the first index should be what you need to get. Then simply click on this download button and extract the downloaded archive somewhere safe on your storage. In there, you will find different versions of ACES, and we will work with the latest one, which is 1.2 at the time of this recording. The next thing we need to do is to make sure Octane is aware of this OCIO config file, and the best way to do that is to define an OCIO environment variable that would point to this OCIO config file. It is very simple. Just search for environment variable on your PC. It will open up the system properties window. Under the advanced tab, click on this environment variable button to open up the environment variables window. And under system variables, click new. The variable name should be OCIO with capital letters. And for the variable value, click on this browse file and load that config.ocio file and then press OK. And now you are set up properly. Next, you need to make sure to restart Cinema 4D again if the environment variable wasn't set up before opening Cinema 4D. Now let's open up Octane settings window, go to the settings tab and open up the color management tab. And here we have this environment config file, which points to the environment variable that we just defined. So we don't really need to do anything here. If you haven't defined an environment variable and want to define the config file manually each and every time, simply enable this use other config file and use this browse button to load the config file that you downloaded manually. We don't need to do that here. So let's clear the path and disable the checkbox, and also enable this automatic recommended checkbox for this intermediate color space section. Next, open up Cinema 4D's render settings and come down to the Octane renderer. Under the main tab, come down to the settings section. Make sure the color space is set to ACES 2065-1 or ACES CG, but ACES 2065-1 is recommended more, as I explained a few minutes ago. And the buffer type is HDR float 32-bit. Next, we need to head back to the Octane settings window and go to the camera imager tab, then the OCIO tab, and then change the OCIO view to ACES sRGB. Then go to the Imager tab and change the response to linear. The settings under the Imager tab can be overridden by the camera in the scene, so we can select the Octane camera tag and under the Camera Imager tab, change the response to linear here as well, because if you just do it in the Octane settings, it will be applied to the scene globally, but if you have a camera with the Camera Imager enabled, the settings in the camera will be used. And the last step is to open up the live viewer. Let's start a render and simply change the live viewer color space to OCIO sRGB. And this will apply the sRGB transform to the ACES OCIO rendered image. And now we are fully in ACES and viewing the final result in sRGB. If I close the live viewer and start a render in the picture viewer, you notice the render does not look like the render we had in the live viewer because this is the raw ACES render without the sRGB transform applied to it, which is what you want for a final render. But if you want to see the same look as you saw in the live viewer, simply change the view or simply change the picture viewer's view transform to ACES 1.0 SDR video, which essentially functions as an sRGB transform and would give us the same look as the picture as the live viewer. You normally want this to be set to raw in the picture viewer, so Cinema 4D wouldn't apply any color transformation to the final render. Then you would apply that sRGB or Rec 709 or whatever color transformation that you want in post, which we will learn how to do that when we learn more about ACES in the rendering section of the course. Let me close the picture viewer for now. And the next thing we need to do is to make sure that our textures and HDRIs are properly interpreted to work with ACES, which is quite easy to do in Octane. Let me open up the node editor for this wood or parquet material from the material manager. Let me also unlock the resolution in the live viewer and arrange these windows so we can see them both. If I select this image texture node that controls the base color input of the standard surface material, you notice we have this color space dropdown for any texture that we load. You basically have three types of textures. Textures that control your color inputs like your diffuse or reflection color, textures that control the data inputs like reflection glossiness or roughness, normal or bump inputs, displacement inputs, and finally, your environment and HDRI textures. For these three types of textures, you need to consider proper color spaces. So let's take this wood shader, for example, that is being applied to this backdrop geometry in the scene. The base color of the material is being controlled by this parquet texture that is loaded using an image texture node. And as it is a color input, set the color space to sRGB. You should treat all your color input textures like this one. For the data inputs, the color space should be set to non-colored data. For example, if I select this roughness map, I have changed the color space to non-colored data already. And if I change it to sRGB, for example, you notice the roughness appears wrong in the render. So let's set it to non-colored data. And the same thing is true for the normal or bump map inputs. I also have this octane sky in the scene that works as my only light source, and I have assigned an HDRI map through an image texture node, as you can see. For these types of maps, the color space should be set to non-color data as well, which doesn't apply any correction to these textures, because usually the HDRI maps don't have that gamma correction applied to them, so we don't want to change that at all. If I try sRGB color space for the HDRI, you notice it will ruin the lighting. Finally, I want to show you how to save out your renders properly when implementing ACES. Let's start with the live viewer. The following section is very important and you might need to come back to it a few times throughout the course, so make sure to pay attention. Now let's again open up the live viewer, lock the resolution, and start a render. Now the render is finished. Let's say I want to save out this image as PNG with the sRGB transform baked in. So from the file menu, choose save image as. Change the file type to PNG, maybe 16-bit. Change the color space to OCIO, and from the pop-up menu, choose color space, output sRGB. And that's it. Click on save. Let's go to desktop and let's name it weird underscore objects underscore LW for live viewer and underscore PNG, and then click save. Now, if I open up the saved image, it looks exactly like the render in the live viewer. Now, if you want to save it as a raw OpenEXR, the bit depth can be 16 or 32-bit, and we will set the color space to ACES 2065-1, the same rendering color space we have been using. Click save and name it weird underscore objects underscore LW underscore EXR and click save. Now let's go to the Fusion and take a look at the EXR image we just saved out. So here we are in Fusion. Let's bring in that EXR image in and see what we have on the left view. You notice this is a raw EXR without the sRGB transformation applied to it. So it is still in ACES, and to see it properly, we need to apply that sRGB transform manually here. And to do that in Fusion, simply add an OCIO color space node and add it after the loader node that loads the EXR render. Now load the OCIO config file that we downloaded earlier in this video, and let's view this node on the right viewer. So again, the source space is ACES 2065-1, and we want to transform that into sRGB. So change the output space to output sRGB. Now we have the same look as the live viewer. Now we can save this out from Fusion with a saver node to any format that we want. Now let's get back to Cinema 4D and let's say we want to use the native Cinema 4D workflow to save out a raw EXR. So open up the render settings window, enable save. Let's save it to desktop and name it weird underscore objects underscore C4D underscore EXR. Change the format to OpenEXR. Here the depth has to be 32-bit for it to be saved correctly. Now let's start a final render in the picture viewer. Now the render is finished. Let's go back to Fusion and drag in the EXR render we just saved out. And it looks exactly like the raw EXR render we saved out from the live viewer. And the same way, we just need to apply the sRGB transformation to it. So let's copy the OCI color space node and connect the newly imported EXR to it. And now if I view this color space node, it looks exactly like the render we saw in the live viewer. And now you can save it out of Fusion to any format with a saver node. Let's get back to Cinema 44 now. Now, if you want to save out a PNG or JPEG out of the picture viewer, just change the view transform to ACES 1.0 SDR video. From the file menu, choose Save Image As. Let's choose PNG, 16-bit, click OK. Name it weird underscore objects underscore C4D underscore PNG. And click Save. Now, if I open up the saved out image, you notice it looks accurate and like what we see in the picture viewer. But the best way to save images out of Octane is through the Octane's own workflow. Saving through Cinema 4D's native workflow has some limitations, which we'll learn some of them as we go through the course. And you don't want to really save out from the live viewer because live viewer does not represent, for example, motions and animated sequences quite well. So we have to, if you want to save it properly, we have to use Octane's native workflow. Let me just open up the Cinema 4D settings window and clear out the save options here and come down to the Octane render section and go to the render AOV group. This is where you manage your AOVs or render passes. All the passes that make up the final render, you can save them out separately and composite them if you wanted to. You can also save out your final beauty pass right from here. First, let's check this enable checkbox. Then let's say we have multiple AOVs. So let's click on this render AOV manager button and let's add a bunch of AOVs like diffuse, reflection, refraction, subsurface scattering, and transmission. Now let's use this render pass file field to define where we want to save out the render. So go to desktop and name it weird objects, weird underscore objects underscore EXR underscore Octane. And click save. The format is set to EXR Octane, which is the best format to save out your renders. We can save out a 16-bit here, but to be sure, let's change it to 32-bit. We'll learn more about dealing with ACES in post, both in Fusion and in After Effects in the rendering section of the course. Then make sure to enable this Save Beauty checkbox Otherwise, only the AOVs that we added a few moments ago will be saved out, but not the final beauty render. So have it checked. Now we can start a final render in the picture viewer. Now the render is finished. Let's head back to Fusion, drag the new render in, and let's view it in the left image viewer. Again, this is the raw EXR render. Let's copy and paste one of the color space nodes and add it after the new loader node, and view the new color space node in the right view. And this is the render after the sRGB ODT or output device transform is applied. Now, if I select the loader node and go to the format tab, we have the beauty pass, but also all the other AOVs that we added. And we can use them in the compositing stage. So we discussed all the ways to save out from Octane while working with ACES. Also, ACES will be discussed later on in more detail, as I mentioned, but this lesson was designed so you are able to follow along properly if I used ACES workflow in any of the future lessons, which is basically every lesson, mostly every lesson. Thanks for watching. See you in the next one.